IFR procedures and navigation data are constantly changing, and Jeppesen approach charts reflect this dynamic character of instrument flight operations. This program, entitled Approach Charts, is designed to help you easily recognize and understand the features depicted on Jeppesen charts and to increase their usefulness when you plan and fly instrument approaches. Before beginning, it should be noted that Jeppesen does not create the criteria or devise the procedures for an approach. This is done by the governing authority in each country. In the United States, this authority is the Federal Aviation Administration. Jeppesen takes the textual description of the approach, which has been created by the governing authority, and converts it into an easily readable chart. Let's take a look at a typical approach chart to see what information is provided. For part of this discussion, we'll use a fictitious location called Terps, California. This program emphasizes Jeppesen's original approach chart format, with enhancements such as big and bold type for selected frequencies, fixed names, bearings, and altitudes. At the conclusion of this program, a brief overview is presented of Jeppesen's new approach chart format based upon a standardized briefing strip concept. As charts are converted and phased in, the new format will become the Jeppesen standard layout worldwide. To fully analyze the approach chart, we'll break it down into 4 sections: the heading, plan view, profile view, and landing minimums. Then we'll discuss the airport diagram, which is usually found on the reverse side of the first approach chart. The airport information is listed at the right side of the heading box. All Jeppesen civil approach charts are filed alphabetically by city name within a state. The city name is shown in bold print for easy recognition. Below the city is the airport name. Next, the specific procedure is noted. The name of the procedure identifies the type of approach and the navigation facilities required. When DME is part of the procedure name, DME equipment is required to shoot the approach. Where straight-in minimums are not provided, the approach is identified with a letter and only circle-to-land minimums are specified. Here you can fly the circling approach by using either the VOR DME RNAV or by using Global Positioning System. When GPS can be used for the approach, the 4-letter Jeppesen Nav Data Airport Identifier is added to assist in selecting the appropriate airport information from the GPS database. This section of the chart also includes the procedure's primary navigation aid and frequency along with the identifier. Below this is the airport elevation, which is the highest usable landing surface on the airport. In contrast, the touchdown zone elevation is the highest elevation within the first 3,000 feet of the landing surface. To the left of the airport information is a small circle which shows the minimum safe altitudes, or MSAs, for the approach. The altitude shown in each sector provides a minimum of 1,000 feet of obstacle clearance within a 25 nautical mile radius of the navigation facility listed below the circle. If the normal 25-mile radius does not apply, it is noted below the navigation facility identifier. Notice that the sectors are formed by magnetic bearings to the station. In this example, the northeast sector is formed between the 180 and 270 degree bearings. There are 2 things to remember about MSAs. First, if the navigation facility for the approach does not provide full azimuth reference information, such as an ILS, the minimum safe altitudes may be based on the primary omnidirectional facility in the area. In the case of current RNAV approaches, MSAs are predicated on an RNAV waypoint, which is usually the missed approach waypoint. The second consideration is that the MSAs may be different for each approach at the same airport, because the approaches themselves may use different facilities. The chart revision date and the effective date are shown above the MSA. You should never use a chart before 0901 Zulu on the effective date. If there isn't an effective date, then the chart is for use upon receipt. The chart index number is listed to the right of the revision date. This number helps you group your charts in the proper order and enables you to locate a chart quickly for revision. The first digit represents the airport number. Additional airports listed under the same geographic location are arbitrarily assigned other numbers. Since these numbers are arbitrary, they do not necessarily indicate airport capability or importance. The second digit indicates the chart type. The meaning of each digit can be found in the introduction section of your airway manual. You should refer to this section whenever you're in doubt about the meaning of a particular symbol. The last digit is used for filing more than one approach of the same type. For example, 11-5 is the ILS runway 12 right approach at Lambert St. Louis International Airport. 11-1, 2, 3, and 7 are other ILS approaches at St. Louis.
This is Terps International Airport Information Mike. The 0245
Moving to the communications box, notice that the frequencies are listed in the normal sequence of use when arriving at an airport. ATIS, approach, tower, and then ground. At larger airports, separate frequencies may be used, depending on the sector from which you're approaching. At Los Angeles International, the approach control frequencies are sectorized. There are also different tower frequencies, depending on whether your destination is the north or south complex. You should also look for special notes or symbols in the communications box. For example, Cedar Rapids approach, tower, and ground frequencies do not operate continuously as noted by the asterisk symbol. When Cedar Rapids approach is not operational, you should use Chicago Center for approach clearance. In addition, when the tower is not in operation, the tower frequency is used as the common traffic advisory frequency. In some cases, local airport advisories can be received from the flight service station. The next section we'll look at is the plan view. To help you measure distance, a mileage scale is located along the left side of the chart. Normally, this scale is 1 inch equals 5 nautical miles. However, if the geographical area is large, the scale could be 7.5 nautical miles per inch. Latitude and longitude lines are shown in 10-minute increments along the inside edges of the plan view. In this case, 35-30 represents 35 degrees 30 minutes north latitude, and 119-10 represents 119 degrees 10 minutes west longitude. The primary airport is depicted with its corresponding runway layout. Other airports in the vicinity are shown screened for reference. These include airports with an instrument approach and others which underlie the final approach course. A star symbol represents a lighted beacon. The NavAid symbols shown on the plan view are similar to those found on other Jeppesen charts. For example, an NDB is depicted by a series of concentric dotted circles. A VOR is indicated by a compass rose. A TACAN, or DME, is depicted by a serrated circle. And a VORTAC, or VOR-DME, is shown by combining the two symbols. Localizer, ILS, LDA, SDF, and MLS approaches are shown with a half-feathered arrow, while a localizer back course approach is indicated by a half-solid arrow. NavAid information for the approach is printed on the plan view. The information for the navigation facility providing the final course guidance is included in a shadow box. The NavAid information for other facilities does not have this shadow. These boxes contain the facility name, frequency, identifier, and Morse code. If a D appears in the box, it indicates the facility transmits DME information. For VORs, a letter T appearing in the box indicates that the station is a terminal class facility. These nav aids are used primarily as approach aids and are normally not part of the en route structure. An L indicates a low altitude class VOR, while an H is used with high altitude stations. If the facility is a localizer, ILS, LDA, SDF, or MLS, the nav aid information is enclosed in an oval. On localizer backcourse approaches, the front course is also included for aircraft with HSI equipment. By setting in the front course, the HSI displays normal sensing. Some man-made and natural objects are depicted on the plan view as reference points. Generally, reference points which are less than 400 feet above the airport elevation are not shown. A dot is used as the reference point for natural objects, while an inverted V symbol represents unidentified man-made reference points. When man-made objects are known, they are depicted with specific symbols, such as a tower or building. The mean sea level elevation, as measured at the top of the reference point, is given next to the symbol. Where the elevation of the object has not been accurately surveyed, a plus-minus symbol is placed near it. The highest reference point portrayed on the plan view is indicated by a bold arrow. Generalized terrain contour information may be depicted when terrain within the approach chart plan view exceeds 4,000 feet above the airport elevation, or when terrain within 6 nautical miles of the airport reference point rises to at least 2,000 feet above the airport elevation. Now let's look at the various flight paths illustrated on the plan view. Besides the various segments, approach transitions may also be shown to assist you when departing the en route structure for the initial approach fix, especially where the IAF is not part of the en route structure. There are several approach transitions on the TERPS plan view. One starts at the TERPS VOR. Another begins at Taylor intersection. And another at Berry intersection. All three are flyable routes which provide at least 1,000 feet of obstacle clearance when you're flying at the prescribed altitude. This obstacle clearance extends 4 nautical miles on either side of the charted course. You can tell if a route is flyable by noting several items. The magnetic course is shown with the course line, and the nautical mile distance is printed next to the line. The route has a minimum altitude such as 5,000 feet. In addition, a flyable route uses a heavier line weight and a larger arrowhead than the line used to indicate VOR cross radials or NDB bearings forming a fix. Notice the difference between the line from Taylor to Quist and the line from TERPS VOR designating the 122 and 149 degree radials to the DME arc. These last two radials are not flyable routes. The 122 degree radial marks the beginning of the DME arc. The 149 degree radial is called a lead radial. It provides you with a lead point for making your turn from the DME arc to the inbound course. Notice how the DME arc turns inbound at this point. Where space is limited, the information for a route is printed below the facility box. For example, Coop intersection is formed by the 239 degree radial of El Nido Vortac. As the note indicates, this radial is also a flyable route. On some routes, you must fly a heading rather than receive course guidance from a navigation facility. Where this occurs, the letters HDG are printed near the route. The initial approach fixes are indicated on the plan view with the notation IAF. In this example, there is an initial approach fix at Nagel intersection and another on the DME arc at the 122-degree radial of the Terps VOR. There is also one located at Quist. An initial approach segment is shown extending from each of these IAFs. If a procedure turn is authorized, it is depicted on the plan view. When this type of symbol is used, you may reverse course any way you desire as long as you stay within protected airspace. You must also stay at or above the minimum altitudes and within the distances shown on the profile view. However, some course reversals are not optional. When a procedural track is charted, such as this teardrop or this holding pattern, you must fly the procedure exactly as shown unless you're being radar vectored. Where the notation "no PT" appears, a procedure turn is not required or authorized. The intermediate segment for this approach at Terps when arriving from the southeast begins at Stein intersection, or when you're aligned with the final approach course after flying the DME arc, or after flying the procedure turn. While on the intermediate segment, you are provided with a minimum of 500 feet of obstacle clearance. The width of this segment tapers from 4 nautical miles on either side of the course at the start of the segment down to as little as 2 nautical miles at the final approach fix. The final approach segment begins at the final approach fix. On a precision approach, this is where you intercept the glide slope at the minimum glide slope intercept altitude. This interception usually occurs near the outer marker, which in this case is Quist. The symbols at Quist indicate that a non-directional beacon is co-located with the outer marker, shown with the fan symbol, and with an intersection shown with a triangle. Therefore, if you're unable to identify Quist with your marker beacon, you can use the ADF or the VOR receiver to identify this fix. The final approach segment ends at the runway or the missed approach point, whichever is encountered last. The initial maneuvering course for the missed approach is shown on the plan view by a dashed line. Where information concerning the missed approach continues off the plan view, an inset is provided. The inset area is not drawn to scale. Exact details of the missed approach procedure are specified below the profile view. Where just the word climb appears, such as climb to 2000, you're required to climb straight ahead. Any turn is indicated in capital letters. With the advent of GPS approaches, additional information has been added to the plan view of Jeppesen approach charts. For example, to help pilots identify the waypoints utilized throughout a GPS approach, Jeppesen nav data identifiers are shown. These are the same identifiers which will appear in your GPS display and help you visualize your next active waypoint as you sequence through the approach. Now let's discuss the profile view on the Terps California chart. This section of the approach chart is a side view of the procedure, but is not drawn to scale like the plan view. The profile view simply depicts the altitudes, fixes, distances, and magnetic courses to be flown. The dominant feature is the heavy solid line representing the flight path. Before glide slope interception, this line represents the flight path for both the precision and non-precision approach. From the glide slope interception point, it only represents the precision approach. The non-precision approach path is depicted by a dashed line. The flight path begins in the procedure turn and descends outbound, which for this approach is shown to the right of Quist. The minimum MSL altitude is shown above the solid flight track line. The direction of course reversal is depicted in the plan view. The number enclosed in parentheses shows the height of the flight path above the runway touchdown zone, not the height above the ground. For example, when you're flying at an altitude of 4,900 feet MSL on this approach, you are 2,427 feet above the runway touchdown zone. However, since this is part of the initial segment, your obstacle clearance may be as little as 1,000 feet. To the right of the altitude designation is the notation 10 nautical miles, which means the procedure turn must be completed within this distance from Quist. As you establish your aircraft on the inbound course, which is the intermediate segment, you can begin your descent to 4,300 feet. On an ILS approach, the point where the solid line begins to descend represents the point where you'll intercept the glide slope when you're at the minimum glide slope intercept altitude. For a precision approach, this is the final approach fix, or FAF, and the beginning of the final approach segment. The notation GS 4233 represents your altitude when you are on the glide slope as you pass Quist. For the localizer, glide slope out, or non-precision approach, however, you cannot begin your descent from 4,300 feet until you reach the final approach fix, which is indicated by the Maltese cross symbol. For this localizer-only approach, the dashed flight path indicates a descent from Quist to the minimum descent altitude. The flight track continues level at the MDA to the missed approach point, or MAP, identified by the letter M on later edition charts. The track then turns sharply upward, ending with an arrowhead. This shows the beginning of the missed approach procedure in the event of an unsuccessful approach. The missed approach point for a precision approach is shown close to the middle marker where the solid line indicates climbing flight. Notice that the missed approach at the decision altitude does not indicate level flight, since you must make an immediate decision to continue the approach or execute a missed approach when you reach the DA. The threshold crossing height, or TCH, is listed to show the height above the runway threshold where your aircraft's glide slope antenna will be if you maintain the ILS glide path to touchdown. A threshold crossing height is not shown on non-precision approaches. The touchdown zone elevation, or TDZE, is shown next to the runway symbol. This is the highest elevation in the first 3,000 feet of the landing surface. It may be lower than the airport elevation, which is the highest point of an airport's usable runways. Two sets of nautical mile distances are located near the bottom of the profile view. The numbers below the line relate to the distance from the landing threshold, as noted by the 0 at the runway symbol. Those above the line represent nautical mileage between fixes. In this case, the distance between the locator outer marker and the middle marker is 4.8 nautical miles. While this profile view is typical of most ILS approaches, it's important to look at a few variations. Unless otherwise noted, profile views depict minimum altitudes. This altitude, however, is listed as mandatory, so you must cross buddy marker at exactly 3,000 feet. Here, the abbreviation MAX indicates a maximum altitude, and MIM means minimum. On this approach, you must cross Bassett intersection between 7,000 and 6,600 feet MSL. This approach shows various step-down fixes which are used to help you descend to a lower altitude. The circled number refers you to a note located elsewhere on the chart. This note indicates that you should maintain a minimum altitude of 10,000 feet unless you are assigned a different altitude from ATC. After you have passed the boo-boo intersection, which may be identified by the 21.8 DME of the ILS localizer, you can descend to an altitude of 9,000. After passing 16.5 DME, which is Bengal intersection, you may descend to 8,000 feet to intercept the glide slope. However, for the localizer-only approach, you may descend to 7,000 feet. The symbol V represents a visual descent point, or VDP, for a non-precision approach. It is the location where you may begin a normal descent from the MDA if you have the runway environment in sight. If VASI lights are installed at the airport, your aircraft should be on the VASI glide path at the visual descent point. This VDP is identified by the 5.1 DME fix. This point is an advisory fix, as noted by the thin vertical line. To descend, the approach threshold of that runway or approach lights or other markings identifiable with the approach end of that runway must be clearly visible. When a course reversal is not authorized, you will see this format. Note the absence of a solid flight path line below the 2,000-foot altitude to the right of the VOR. This indicates that 2,000 is the beginning altitude for the straight-in procedure. On this approach, the two facing arrows indicate you must use a holding pattern as your course reversal. You can find the direction of the turns on the plan view. 1-minute legs are specified for this holding pattern, and both legs are flown at 2,700 feet. On this approach, you must fly the outbound heading no lower than 1,500 feet. When you're established inbound and have been cleared for the approach, you can descend to 1,200 feet. This procedure turn depiction shows that you can descend to 3,500 feet while outbound. Then, when established on the inbound course, you can descend to 3,000. Here you may descend down to 3,000 feet while outbound on the procedure turn. You then fly the inbound leg at a level altitude until reaching Cody intersection. This does not preclude you from continuing your descent down to 3,000 feet if you have not reached that altitude prior to intercepting the inbound course. A Category 2 ILS uses the same basic format as a standard ILS, but does have some specialized information. For example, notice that there are 2 decision altitudes on this approach. This is because the lowest available Cat 2 minimum is normally a decision height of 100 feet above the touchdown zone elevation. When certain airborne equipment is out of service, or when pilot and operator requirements preclude the use of the lower minimum, normally a decision height of 150 feet applies. The RA entries indicate that the decision height can be determined by radio altimeter. This type of instrument displays the actual height above the ground. Now let's take a moment to look at the missed approach procedure as indicated by the curved line and arrowhead. A missed approach from an ILS generally requires you to maintain a straight climb to a specified altitude before turning, usually a minimum of 400 feet. A non-precision approach, however, often requires an immediate climbing turn. The reason for this is that an ILS missed approach normally begins about 200 feet above the runway elevation, but can be even lower on Category 2 or 3 approaches. These altitudes do not ensure adequate obstacle clearance if you begin an immediate turn. On some non-precision approaches, however, the MDA may be high enough to permit the turn as you initiate a climb. Because each missed approach is unique, be sure to read the procedure carefully and compare it to the missed approach track in the plan view to make sure you fully understand the procedure. When a missed approach procedure calls for a turn, it's important to understand that the obstruction clearance criteria are figured from the missed approach point. If you begin a missed approach prior to the MAP, you may pull up and begin a climb, but you may not begin the turn until you have reached the missed approach point. Now it's time to discuss the last and one of the most important sections on the approach chart, the landing minimums. Landing minimums usually increase when a required component or visual aid becomes inoperative. Jeppesen presents this information in a logical sequence. For instance, the lowest minimums are located on the left side of the box. As you move to the right, the minimums increase. On most approach charts, the minimums table actually represents two groups: straight in and circle to land. On ILS approach charts, the straight-in landing section is further divided into minimums with and without the glide slope. On the left-hand side of the minimums box, aircraft categories are represented by the letters A, B, C, and D. The first column of an ILS approach is designated as full. The minimums within this column apply when all components are operational. In this example, no matter which category of aircraft you're flying, you can descend to a decision height of 200 feet above the touchdown zone elevation, which at this location is a decision altitude of 2,673 feet MSL. Notice that these figures are labeled DA parentheses H. The DA, or decision altitude, is the MSL altitude where you must make your decision to execute a missed approach or to continue the approach. The DH, or decision height, is shown within the parentheses. For the full ILS, you must also have a touchdown runway visual range of 1,800 feet, or if RVR is not reported, a visibility of 1/2 statute mile. As you move to the right, you can see how the visibilities change for various inoperative lights. If more than one component is inoperative, you must use the more restrictive minimum. For example, if both the runway centerline lights and approach light system are out, use the minimums listed in the ALS out column. For the localizer, glide slope out, or non-precision approach, the figures are labeled MDA parentheses H. The MDA, or minimum descent altitude, is the MSL altitude below which descent may not be made without visual reference. The H, or height, is shown within the parentheses. On the far right are the circle to land minimum altitudes and visibilities. The protected airspace during a circle to land maneuver depends on your aircraft's approach category, which is based on its airspeed. This airspace ranges from 1.3 nautical miles from the runway ends for Category A aircraft to 2.3 nautical miles for Category D aircraft. Remember, if you're flying the maneuver at an indicated airspeed faster than the maximum limit of the speed range for your category of aircraft, you should use the next higher speed range. Otherwise, you might not have the necessary obstacle clearance. The altitudes in parentheses show heights above the airport. These numbers are not based on heights above the touchdown zone because circling minimums are not referenced to a specific runway. A note in this section indicates that circling approaches are not authorized northeast of runway 12 left and 30 right. One reason may be due to high obstructions within the circling approach area. Again, it's important to look at some variations in the minimums box. For example, on this approach, notice that there is a decision altitude and height penalty when using a remote altimeter setting. At this location, you can go to lower minimums if you can obtain a local altimeter setting. This example shows an approach which doesn't have straight-in landing minimums. Remember, straight-in minimums are omitted when the final approach is not aligned within 30 degrees of the runway, or where an excessive rate of descent, generally over 400 feet per nautical mile, would be required between the final approach fix and the missed approach point. On the other hand, you are not prohibited from landing straight in when an approach does not show straight-in landing minimums, provided you break out in time to position your aircraft and make a normal final descent to the runway. Notice that there are different minimums for this approach, depending on whether or not you can identify Fernie intersection. Since Fernie is a step-down fix, once you have identified and crossed it, you can descend to the lower minimum altitude. Below the minimums box is a conversion table. For a precision approach, the middle row relates the aircraft's ground speed to the rate of descent necessary to maintain the glide slope. You can use this information to help determine the presence of a headwind or tailwind. For example, the table shows that at a ground speed of 120 knots, you must maintain a descent rate of approximately 647 feet per minute to stay on the glide slope. If you notice that a rate of 800 feet is required to remain on the glide path, a tailwind may be present. If your wind estimate varies markedly from the reported surface winds, be prepared for possible wind shear during the approach. The bottom line shows the elapsed time from the final approach fix to the missed approach point. It applies only to non-precision approaches because the MAP location for the non-precision approach is usually the runway threshold. The MAP for an approach using glide slope information occurs approximately 1/2 mile from the threshold when you reach the decision altitude while on the glide slope. When the conversion table is blank, the missed approach point is not based on elapsed time or ground speed, but rather is a specific point. The MAP in this example occurs at the NDB, which is located at the airport. Just below the conversion table is a revision note to inform you of important changes which occurred during the last revision. In some cases, you'll find that the changes have occurred on the other side of the chart. When airborne, you have plenty of navigation information to help you locate your position. But once on the ground, orientation becomes a different challenge, especially at unfamiliar airports. The airport chart is a valuable aid in this situation. It is usually located on the reverse side of the first approach chart for each airport. The communications box lists the radio frequencies in their sequence of use for departure. If available, the VOT frequency is also listed. The geographical coordinates for the airport are shown beneath the city, state, and official airport name. This is followed by the airport's magnetic bearing and distance to the airport from a nearby VOR-DME or VORTAC. The airport's elevation and magnetic variation are listed next. The plan view contains an airport diagram which is drawn to scale, except for the width of some taxiways. Since the scale used for the airport diagram may vary from chart to chart, a bar scale is provided to indicate the diagram dimensions. On plan views, latitude and longitude tick marks are shown around the outside edge. This helps you determine your exact location on the airport if your aircraft is equipped with a latitude-longitude navigation system. The airport diagram has several features that help you familiarize yourself with the airport. To avoid confusion, each runway is shown in black, while taxiways and ramp areas are printed in a lighter shade. The runway number, and when available, the exact magnetic bearing and runway end elevation are also shown. Some of the symbols on the plan view include the bar across the runway, which indicates a displaced threshold. In this case, it is associated with runway 30 right. The note and the reversed color runway at the approach end of 30 left depicts a 200-foot overrun. If an approach lighting system is installed, a symbol showing the lighting array is printed at the appropriate runway end. For a detailed description of the lighting systems, you can refer to the approach chart legend pages. When appropriate, taxiways are labeled by letter designators. Notice that Terps Taxiway Gulf is a parallel taxiway for runway 6 and 24. The airport reference point, abbreviated ARP, shows the intersection of the geographical coordinates published for the airport. Keep in mind that an ARP may not be designated for every airport. The additional runway information section presents more detailed information than can be shown on the plan view. Included in this section is a listing of each runway with its lighting systems, including VASI or related systems, and whether the runway is grooved. Also included are the usable lengths of the runways beyond the threshold and glide slope, and the usable takeoff distance if the takeoff is restricted. The last column shows the width of the runways. The bottom portion of this section identifies special runway information. This information is noted by ball flags in the runway column. The last section of the airport chart shows takeoff and alternate minimums. The title Takeoff and IFR Departure Procedure is used to indicate that both takeoff minimums and IFR departure procedures are specified. The specific departure procedure for each appropriate runway is contained in a textual format. When an IFR departure procedure is not specified, this table is just titled Takeoff. Within this section, the standard and lower than standard takeoff minimums for individual runways or groupings of runways are shown for commercial operators and air carriers. For example, the STD column under each grouping reflects the standard takeoff minimums prescribed in the FARs for aircraft with 1 or 2 engines, and for aircraft with more than 2 engines. Remember, if you're operating under Part 91, you are not required to comply with the published IFR takeoff minimums. However, you should realize that these minimums have been established for the operation of commercial aircraft. Therefore, it is wise to comply with the standard minimums. Also keep in mind that the publication of lower than standard minimums does not constitute authority for use by a given commercial operator. To be able to use the lower minimums, commercial operators must obtain appropriate approval in their operation specifications. For example, if the centerline lights and runway centerline markings are available on runway 12 left, 0 right, some operators can take off with as little as 600 feet RVR, providing there are at least 2 operational transmissometers. The next column, entitled Adequate Visual Reference, is another lower than standard category which may be permitted for some operators. What this means is that you must have a visual reference which allows you to continuously identify the takeoff surface and maintain directional control throughout the takeoff run. This is usually provided by runway markings or lighting. Notice that in order to take off on runway 6 with at least the standard visibility minimum, you must be able to maintain a minimum climb rate of 340 feet per nautical mile to 3,100 feet. If you are unable to meet the climb requirement, you must have a ceiling of at least 300 feet and 1 statute mile visibility. To the far right of the chart, the alternate airport weather minimums are published. These minimums are listed only when the airport may be used as an alternate on your flight plan. Where the airport is not authorized as an alternate, the notation NA appears in the box. The proper execution of an IFR approach takes planning, coordination, and the ability to accurately extract information quickly from the charts. You should never take anything for granted. Even if you have performed the same approach many times, it's important that you review the charts and check for any recent changes. Now that we have completed our review of Jeppesen's original approach chart format, let's take a look at the new approach chart format based on the briefing strip concept. Eventually, all Jeppesen approach and airport charts worldwide will be converted to the new format. The general layout of the new approach chart format includes the following sections: Heading, Plan View, Profile View, and minimums. The heading section consists of heading information, communications, pre-approach briefing information, and the minimum safe altitude, or MSA, graphic. The plan view section includes the approach plan view graphic. The profile view section contains the profile view graphic, conversion tables, and icons. The minimum section contains landing minimums. Basic approach information is presented in the sequence in which pilots would normally brief or review the procedure prior to flying it. The new format incorporates human factors evaluations, a standard pre-approach briefing sequence of information, crew resource management or CRM techniques, and an emphasis on usability and legibility. Rearrangement of information on the new chart format concerns how pilots review and use the chart data. For example, the upper right corner of the heading information is accessed first by most pilots. The flow is then right to left, and the arrangement of information is designed to keep it visible even when the chart is clipped to the control column. Pilots typically refer next to communications, then through the pre-approach briefing information and MSA. The typical usage pattern continues down through the approach plan view graphic, profile view graphic, conversion tables and icons, then finally into the landing minimums. As we examine the new chart format in more detail, notice that the location name and procedure identifier help you quickly identify and retrieve the approach to be briefed and flown. At a location, charts are grouped or indexed by similar procedure type: ILS, VOR, NDB, etc., and sequenced according to runway number, lowest to highest. For example, ILS runway 16 is before ILS runway 34. To verify that the selected chart is correct and current, pilots review the grouping of the Jeppesen nav data, or ICAO, airport identifier, the airport name, chart index number, and date. Communication frequencies are arranged horizontally. Notice that the frequencies are listed left to right in the normal sequence of use from arrival to touchdown. The pre-approach briefing information and MSA section starts with the primary navigation aid used for the approach. For example, on ILS approaches, this will be the localizer. Included is the nav aid type, identifier, and the associated frequency enlarged and made bold. The final approach course bearing is next, which is also found in the plan view and profile view, and it's depicted in big and bold type. As we continue horizontally, the next box contains the glide slope altitude at the outer marker, or equivalent position for precision approaches, or the minimum crossing altitude at the final approach fix, or equivalent position for non-precision approaches. Notice the use of big and bold type. The name or identification of the associated nav aid or fix is included in this box. Remember, step-down fixes may exist between the FAF and MAP. Refer to the profile view for complete information. Contained in the next box is the decision altitude, or minimum descent altitude, and the box lists the lowest minimum altitude in large bold type, and the height for the straight-in landing. Under certain conditions, this box may contain a note referring you to the minimum section. You should always review the minimum section for complete information. The final box in this row contains the airport elevation and the touchdown zone or runway end elevation in large bold type. On the original chart format, only the airport elevation is found in the heading section. Complete instructions for the missed approach procedure have been moved into the heading section. They are placed here because the entire missed approach procedure is typically referenced during the pre-approach briefing. Additionally, missed approach information is shown in graphical form in the plan view. General equipment or procedural notes associated with the approach are found together in this common placement area of the new format. Altimetry information is also found here. If there are no notes associated with the approach, this row may be omitted. On the original format, notes may be found in various locations around the chart. The minimum safe altitude, or MSA, graphic is consistently placed in this new location for quick and convenient reference. The bearings and radials are oriented to the point of origin. A minimum safe for sector altitude is applicable to a 25 nautical mile radius unless otherwise specified. In the plan view of the new format, the primary navigation aid information is shown using big and bold type and a shadow box for easy recognition. Slight style changes in nav aid box outlines have been made to improve visual appearance. Leader arrows are thinner than the original chart format and contain no arrowhead. Large bold type is used to help recognize and visually identify the names and idents of airspace fixes associated with the approach procedure, along with the final approach course bearing. A layered look intended to improve visual contrast and reduce visual congestion is provided by shading or screening formation radials and secondary airports. There are several enhancements in the profile view graphic. For visual reference, big and bold type is used for the names and idents of airspace fixes associated with the approach procedure. Bold type is also used for the glide slope altitude at the outer marker or equivalent position for precision approaches and the minimum crossing altitude at the final approach fix or equivalent position for non-precision approaches. The profile view graphic also shows the existence of any step-down fixes and altitudes between the FAF and MAP. The final approach course bearing is enlarged and made bold for visual recognition. To reduce visual congestion and enhance chart clarity and recognition of surrounding chart data, the symbols for nav aids and fixes are screened or shaded. The touchdown zone or runway end elevation is also enlarged and made bold. The new format places the conversion tables below the profile view graphic for improved usability. The new position reinforces the relationship between the profile view graphic and the conversion table information. A major addition to the new chart format is the graphic depiction of the applicable approach light system, or ALS, for the straight-in approach runway. When visual descent lighting aids are available, such as RIO, VASI, or PAPI, they are shown on the appropriate side of the runway. An explanation of the symbols used for approach lights is found in the approach chart legend. Another new feature is the addition of missed approach icons. Located below the profile view graphic is a series of symbols which represent initial pilot actions in the event of a missed approach. They provide symbolic information about the initial up and out maneuvers only. In this example, the icons are read as climb to 5,800 feet, then climbing left turn to 8,000 feet, via a 260-degree heading. Always refer to the missed approach instructions in the heading section and the plan view graphic for complete information about the missed approach procedure. The presentation of landing minimums is unchanged in the new format. Big and bold type is used to depict decision altitude, or DA, and minimum descent altitude, or MDA. There is a minor change in the location of notes applicable to landing minimums. These notes are placed in a common location below the landing minimum section. In order to conform with the new approach chart format, some minor changes have been made to airport charts. The heading is rearranged, and communication frequencies are shown horizontally in normal sequence of use. The airport plan view graphic includes a new magnetic variation symbol. Additionally, the airport bearing and distance from a nearby VORTAC is depicted. This information was previously located in the heading of the airport chart. This concludes our overview of Jeppesen's new approach chart format. Remember, it's important to always review the entire chart and all its components prior to use. While domestic instrument procedures are standardized within the National Airspace System, a note of caution. Filing and flying IFR internationally entails procedural and regulatory differences which require special preparation and orientation.